Good morning, everyone. So in the last session, we discussed about the fixed stack as well as the dynamic stack related example here. So using this simple example, like this is the simple logic we implemented. Whenever, so we are trying to give the values if the size is more than, if the size is out of this particular in setting the value. So in that case, we are creating the new temporary int array, and we are trying to copy the original array into this particular temporary, and later, so we are trying to assign into the temporary array into this particular stack. Okay, so finally we are inserting the element here. This is the way this is the way we can create a new array whenever the size is exceeded here. Okay, so this is the important example we discussed in the last session. So today we are going to discuss here one more important information here, how these particular interfaces are extended here, how this particular interfaces can be extended here. So this is also important here. Whenever I want to extend interface to interface, so what is the keyword we are going to use between these particular interfaces here? So again, here whenever we are trying to use the extend keyword here, so either we can go for the class to class or interface to interface. But when we are going to use the implement here, only whenever we are trying to implement from the interface to class, we are going to use the particular implements keyword here. Okay, so let's write the simple example here. So this is the interface name I'm providing. Interface here. Okay, so this particular interface here can contain two methods. Okay, so these are all the two methods I declare inside this particular interface here. Now what I am doing here, I'm going to create one more interface. So this is the interface B, and this interface B, if you observe carefully, it is extends from the interface here. It is extending from this particular interface here, and whatever the method you want to write, you can write here. So something like, if you're trying to write the different method, so here also we are going to declare this particular method here. We cannot write the implementation, because so whatever the method we are writing inside this particular interface, it is a public and abstract here. Okay, so this is the way we can extend the multiple interfaces here. And what you need to understand basically here, whenever we are extending this particular interface, finally we need to write the implementation here. So how I'm writing write this particular implementation? So my class, and this is the my class is going to implement here. And observe here, whenever I'm trying to implement this particular interface B, what happens internally? How many methods we need to override here? Three methods we need to override. So why we need to override this particular three methods? Basically here, the interface B is extending from the interface A here. Getting the point? This particular interface B is extending from this is the interface A, and this is the interface B. Getting the point? So here we are having the relation called extends here. So why we are having the extend relation? Because whenever we are trying to discuss with multiple classes, multiple interfaces here, we are going to write the keyword called extends keyword here, and this is the sub interface, and this is the super interface. Getting the point? So super interface can contain the how many methods we are having? Two methods. Okay, and sub interface can contain the one method. So totally in this particular sub interface, how many methods we are having? Three methods. So here, method 1, so mathematical 2, and 3. So these are all the three methods. So these two are the logically existed and this is the physically existed here. Getting the point. So how it is existing? Because of this particular extends keyword. So this is important, we need to understand. Whenever we are using this particular extends keyword, whatever the super functionality we are having, so that we can copy into this particular sub interfaces or subclasses here. Getting the point. Now inside this particular interface B, how many methods we are having right now? Three methods. So the three methods we are going to implement inside this particular implementation class. Now you can see, so these are all the three methods we are having here. So meth 1, meth 2 as well as this particular meth 3 here. Okay, so you can write whatever you are interested to implement this particular logic here. But here how we are extending is important here. So using this particular extends keyword, we are going to make the relation super interface with the sub interface here. Okay, so simply I'm going to write this particular message here. So implement this particular method 1, and here, so this is the second method I'm trying to implement here as well as the third method here. Okay, so only the name of the method I'm going to modify here, because so we are not going to write much code here. Now you can see these are all the three methods are coming from the way the super interfaces as well as sub interfaces here. And finally what we can do, you can come up with a main class. So using this particular main class you can create an object here. MC is equals to new my class MC dot, you can call the all the methods here. What are all the method we are having, we can call here. So second method as well as third method I'm calling. If I'm going to run here, now you can see whatever the method we are implemented here. So all the three methods are we are able to access here. But here how we are accessing, so this section is important here. How we are making the interface A relation with the interface B. Okay, the relation how we are making using this particular extends keyword. Any questions here regarding this particular interface and interface relations here?
Sir, I have one question related. So we are using inherited class, and we are implementing that class. Means whatever methods it is available in that inherited class, it will be available in that after implement class. Am I right, sir, or anything I'm missing?
See, you can think same like the class related. So if I'm going to write the super class here, if I'm going to write the super class like something like a sum method, this is we implemented in the earlier example. And what we did this super class, if I'm going to make the relation using this particular extends here into this particular subclass. Okay, the sum method is available into this particular subclass also. How it is having because of this relation here. Right.
Yeah.
Now what we are doing here, same way, so this particular methods. So imagine this is the some method we are defining inside the super interface, and we are making the relation with this particular sub interface. This is the sub interface. It's contain the action because of this particular actions keyword. Now we are making the relation to this particular super interface to this particular sub interface. So along with the sub interface, if you are trying to write any specific method, so this method logically available into this particular interface, and same way one method we defined that is called meth3. So this is the specific method. Getting the point. So this the specific method is available in the sub interface, and logically we have a two methods we are available into this particular sub interface. Finally, three methods are available. The three methods are not yet implemented here. So the all the three methods are declared here. So why we are saying this is a declare? Because it is a interface here. Interface by default it is a public and abstract here. Getting the point. Here we don't have a method body, just we are declaring here. You can see in the interface A, so it's contains only two methods, and now inside this particular interface B, it contains only one method. So totally inside this particular interface B, we are having three methods. Two methods are logically available, one method physically available, this method. Now finally what we are doing is we are trying to implementing all the three methods into this particular class. So why we are implementing? Because we are trying to make the relationship with the help of this particular interface B. We are trying to implement the interface B here. So because of this, all the three methods are existed into this particular class.
So we are doing the inheritance concept between two interfaces. After that, we are implementing using the interface to another class. Am I right, sir?
Yes, yes. Because interface can extend here, but here whenever we are extending the interface to interface, we cannot get the method implementation. So even though two methods we are trying to extend, all the methods can contain only declaration only, not the body. So that's why I'm
Yes.
explaining it. So if you see here, I'm trying to write the method body, sorry, method declaration, and here also we are having method declarations. But where we need to implement, like where we can have this particular method body of these three methods. But if I'm seeing the interface here contain the method declaration of these two methods, and interface B also can contain the declaration of this particular method, right? So finally, the particular all the methods be implemented using this particular implements keyword. So first we are extending interface to interface, and later we are doing this particular interface implementation here.
Okay. Thank you.
So, sir, after implement, we can write the business logic here in this class.
Yes, yes. Here only we can write the business implementation because interfaces cannot have the particular method body. Okay, so these are about the interfaces to interface extends keyword, and finally how we can implement this particular interfaces we are defining here. And now, so one of the important concept is introduced in the 1.8, that is called default interface methods here. So how we can write this particular default logic inside this particular interfaces here. So as of now, we did not write any default logic here, but now we'll try to write the default logic here. So basically, if I want to write the default logic inside the interfaces, so we have a one keyword. We are going to use the one keyword. So using the keyword, we can have the method body here. Getting the point. So as of now, we don't have the particular method body in our inside this particular interfaces. But now what we will do, we'll define the method body inside this particular interfaces here. So how we are going to write, this is the simple example we are going to discuss. And here, this particular implementation is introduced from the 1.8 onwards here. Okay, so let's observe here. So this is only the interface I'm having here, and if I'm going to write this particular method body of this method, now you can see I'm getting an error here. So why I'm getting this particular error? Now you can see the suggestions here. We can easily understand how we can convert this particular method. So either we can make the default and we can go for the static. So we'll discuss later the static, and we can remove this particular method body. So directly you cannot define method like this. Directly you cannot define method like this here. Okay, so how we can define? So either you can define the default or you can go for the static. So first we'll discuss about the default, later we can move on to the static here. So now you can see whenever I'm adding the keyword called default here, what happens internally? So we can have the method body of this particular method here. And now what I'm doing is I'm going to print the statement here. So default. Now if you observe carefully, this is the default implementation. The default implementation we define under this particular interface B. Okay, now what I'm doing here, so inside this particular class here, what I'm doing here, again I'm trying to override this particular method here. So what is the purpose of here overriding it? What is the purpose of here overriding? So again, we need to understand here. So what we need to understand here, this is the specific implementation. This is the specific implementation we are trying to write inside this particular class. So if you are not interested to write this particular specific implementation, so you can comment out this section here. Karinaban, you can comment out this particular method and whatever the default implementation we provided here. Whatever this particular default implementation we provided, we can use this. We can use this. So for example, now what I'm doing here. So for example, now what I'm doing here, if I'm going to run this, now you can see, so default, the method, whatever the method 3 we implemented inside this particular interface is executing. Okay. Now finally, what happens internally, if I'm going to enable this particular method again, now if I'm going to run one more time, now you can see the implement 3 method is calling. So this is the line number 19 is printing here. Getting the point. So see the differences here. If you are interested to override this particular method for the specific implementation, we can go for this particular method. So otherwise, whatever the default logic we have, the default logic is going to execute. So if we observe again here, the method overriding concept. So if you override the method, getting the point. If you override the method into the subclass here, the subclass method is going to call. Otherwise, the superclass method is going to call. Same way, so that information we added in the class, the functionality, same functionality is introduced inside this particular interfaces with the keyword called default here. Getting the point. So this is the default implementation here. So to understand more here, now what we can understand here again, the list interface here. So what we discussed in the last session. Now you can see default here. So now you can observe carefully. This is the default here, but list is a interface here. Getting the point. Whatever I'm trying to show here, this is basically is an interface here, but this contain the method here. So this particular method, like what is the method we are having? Replace all method. The replace all method, it is having the method body here. It is having the method body. So if you are not interested to override this particular replace all method, now what we can do? We can use this particular logic here. Whatever the logic we are having here, we can use this particular logic. So same way, we have a lot of methods inside this particular interface. It's contain the default implementation. Now you can see, so sort method. Getting the point. So this is the default implementation of sort method here. Getting the point. So you can override this particular sort method to come up with a specific implementation. Otherwise, we are going to use this particular sort logic here. Okay. So same way what we are doing here. So we are trying to use the default implementation here. So whenever if you are not interested, this particular method is going to call. Otherwise, we can come up with the specific implementation. We can write whatever we are expecting here. Okay, so this is the important information is added inside this particular 1.8 onwards, and the information we are going to write inside this particular interfaces here. Okay, so any questions here?
Sir, do we have a default kind of methods in abstract classes also, or only it is available in interface concept?
Only it is in the interfaces.
Okay.
Sir, like you showed the lots of methods. So do we need to learn all the method name with their
Basically, these all the methods are important methods only. Whenever you are trying to work on the collection related example, so any one of the case we are going to use each method. Like if we want to make something, whatever basically collections are, it's going to store as a multiple values. If you the multiple values, if we want to store in the like ascending order or the descending order, we are going to call this particular method sort method. And the same way, you can see the whatever the method just now we understand replace all. So if we want to replace any one of the element or any one of the like multiple elements here, we are going to call this particular replace all method, and we are going to provide the multiple parameters. Based on that, the values are going to replace here. Okay, we'll discuss about the each and every method, the purpose of the each and every method, because whatever the method we are discussing here, all the methods are important here. Okay, now we'll go to this particular the important information call. So if you are trying to write the like int stack here. So yesterday we discussed about this particular int stack here, and here what I'm doing here, I'm going to write the default implementation of this particular int stack here. So now you can see I'm trying to come up with a clear method, and you can write something. And here, so what I'm doing here, this particular clear method is not implemented. Where it is not implemented inside this particular fixed stack here. Where it is implemented inside this particular fixed stack, where it is here. So here it is not implemented. But even though what happens internally, so we can execute this particular example without getting any error here. So yesterday somewhere we created the object here and we executed this. I hope inside this particular class, I think this. Okay, so here I'm going to run the same example for this particular intersect. Now you can see we are not getting any error, even though if I'm going to add the method inside this particular interface here. So okay, so this is the default logic. For example, now what I will do here, I'm going to call the method call clear method. Here only I'm calling the clear method. Now the clear method will call from the interface here, because the clear method is not yet implemented inside our the fixed stack class here. Okay, so this is the one of the real-time example here, because so this is the way only we are going to write multiple methods inside the interfaces. One method like a common method will come with a default, and a specific method we are not going to use this particular default here directly. We can write like this here. We can declare the method and we can override the method inside this particular subclasses here. Okay, so this is we need to understand the default behavior inside this particular interfaces. Now we'll discuss about the why this particular multiple inheritance are not going to support it at class level, and why the multiple inheritance are going to support at the interface level. Okay, so we need to understand this particular example here. We need to understand this particular example, how this particular examples are going to identify here. So let me write the simple example on this particular multiple inheritance here. So for this particular multiple inheritance here, what is the simple example we can understand? So here, what I will do here, I'm going to write the multiple classes here. Parent one class I'm defining, and inside this particular parent one, so fun method I'm defining. Okay, so this is basically just I want to provide the fun method is called parent one class. Now what I'm doing here, I'm going to write the one more class here. So this is basically parent 2. Now what I will do, I will copy this. Okay, the same fun method I declare inside this particular parent 2. Now what I will do, getting the point. Now what I'm doing here, so I'm going to extend this particular main class here. I'm going to extend main class here. Multiple inheritance test here. Okay, and here I'm trying to use the extends keyword. parent 1 comma parent 2. So now observe what happened internally. So if I'm going to comment out this, now you can see we are getting an error here. So why we are getting an error here? So this particular comma is not able to use inside this particular class here. So what I'm explaining here? So multiple inheritance, basically only one class we can extend here. Only one class we can extend. But here how many classes we are extending here? Two classes. So now you can read this particular error. So we cannot use this particular comma. If I'm going to remove this particular comma, again now you can see parent 2. Parent 2. But how we are going to differentiate the parameter list here? Basically, so using this particular comma only, we are going to differentiate here. Now what you understand here? We cannot extend more than one class. We cannot extend more than one class here. But now what we will do, the same example we'll try to implement with our interface here. Getting the point? So the same example we'll try to implement this particular, we'll try to implement with our the interface concept. But before going to provide this particular information, now what I will do here, instead of coming with this particular multiple classes, now what we can do here, I'm going to write the particular hierarchical inheritance. So that we already identified here. I'm going to come up with the main class here. Okay, so this is the grandparent class I'm defining, and it's contain the same method called the same fun method I'm defining here, and internally I'm going to provide the message here, something like fun method from, okay, grandparent class. Now what I'm doing here, this particular class is the parent one here is going to extends with this particular grandparent, and the same way the parent to 2 also. Getting the point? This particular parent 2 also is going to extend from this particular grandparent. Now finally, so what is the information we are going to do here? Getting the point? So finally, now either any one of the you can use it, either parent 1 or parent 2. Finally, what I want to provide the information, only one class we can extend, not the more than one here. Getting the point? So the initially what we are doing it, initially the hierarchy is important here. We have a two super classes. This is the super 1, super 2. Now finally what I am doing is I am trying to extending into this particular subclass here. I'm extending into this particular subclasses here. Getting the point? Now what happened internally? So inside this particular multiple inheritance here, at a time we cannot extend more than one class here. We cannot extend the more than one class here. So basically this is an hierarchy we are trying to extend here, but it is not possible to extend this information. So this same example, what we will do, so just now one more example I discuss here. So we are having super class and is extending into one subclass and is extending into another subclass. Getting the point? So this is the different hierarchy. So here we are trying to come up with a grandparent here, and finally it's connecting with the parent 1 and it's connecting to this particular parent 2. This hierarchy is different. This is the hierarchical inheritance we are discussing here. Okay. Anyway, if you are trying to discuss with this particular hierarchy, but finally what happens internally, we cannot extend the more than one class here. So either parent 1 or parent 2 we can extend, but at a time we cannot write the parent 1 and parent 2 here. Okay, this is I want to provide the information. And now what I will do, so the same example we are going to discuss with our interfaces. Okay, so let's observe the the same example here. Now what I'm doing is, here I'm going to define the interfaces section. Now this particular interface, what is the name of the interface we can define? Something like multiple inheritance. So basically this is the multiple inheritance interface I'm defining. Okay, now so default, here I'm trying to come up with a show method, and you can write the message. So the default method from this particular multiple inheritance interface. And the same way, so one more interface I'm going to define. One more interface I'm going to define. Something like B. Something like B I'm defining. And now what I will do, I will copy the same message what we implemented here and inside into this particular class here. Okay. So and here, now what I'm doing here. So here I'm having the show method. Okay, in the multiple inheritance interface also we are having one show method. Now finally what I'm doing is I'm trying to use this particular grandparent and I'm going to implement this. Whenever I'm trying to implement, okay, so it is a so multiple inheritance A and multiple inheritance B. Now observe carefully. What happens internally? So this is the implements, it is not giving me any error here. Whatever we used earlier with the comma, it's getting an error. But right now we are not getting. So here you can see, so this is basically, it's giving me the error to implement the particular methods here. So now you can see, so what is the method is expecting to override here? Getting the point. So what is the method is expected to override here? Let me save this and so I want to save this also. Okay, so finally, now what we are doing is, so it's showing the information like what is the method we want to override. So you can override any method here, but observe carefully. How this method is calling is important. How this particular method is calling important here. Okay, so basically this method is going to call on the superclass, this particular inheritance, the inheritance A interface method. But if we want to call the inheritance B interface method, now what we will do, we'll try to change the name of this particular interface here. If you change this name of the interface here, it's going to call the inheritance B interface method. The inheritance B interface method. So for example, here only I will create the main method and grandparent. So GP is equals to new grandparent object I'm creating here. And now you can see GP dot show method I'm calling. Whenever I'm calling this show method, now what happens internally? Which method is calling here? And now you can see multiple inheritance. Okay, I did not modify the message here. I did not modify this particular message here. Now you can observe. Now you can observe. So this is basically, it is going to call the inheritance B here. Right. Now if I'm going to modify this name of the interface here. Now finally it is going to call the particular interface A here. This is the multiple inheritance interface A method is calling here. Getting the point. This is, we need to understand how this particular multiple inheritance is supporting this particular interfaces, not from the classes here. Okay, this is very important here. Any questions? Okay, so this is we understand the default method and how this particular multiple inheritance is not supporting in our Java language. Only it is for the classes, not for the interfaces. Using the interfaces, we are able to access the multiple inheritance here. So how the diagram is look like here? The basically the diagram. This is the interface one I'm defining, or interface A, and so this is the interface B. And what we are doing is the interface information methods we are trying to store into this particular class here. The interface method, even though both interface can contain the same method. So here we define the show method, and here also we define the show method. But finally, what we are doing is, so based on inside this particular subclass, so either if we want to call the interface A method, we are going to call the interface A reference dot, the super interface dot, we are going to call the particular method. And if we want to call the same thing, and we'll define the name of the interfaces. Getting the point? So this is the way we are able to access the specific method which is available inside this particular interfaces here. So this is the diagram is going to look like. So here we have a two super interfaces or two super classes, we can call it here, and one subclass or one. So here we are going to come up with only one subclass. So there is no other information. Even if you are defining the interfaces or if you are trying to define the classes, all information can only access inside this particular subclasses. And here the subclass will have only one. Getting the point? So this is the important diagram. This is nothing but multiple inheritance here. Now we'll move on to the static method. So how we can define this particular static method? So just now we discussed about the default method here. Now we'll move on to the static method. So basically, static method is nothing but instead of this particular default here, we'll go for the static here. We'll go for this particular static here. Now same thing here also I'm going to write static. Now what is the differences here? What is the differences? Basically, we discussed already when we are trying to work on the static at the class level, like static method in the class, static classes, and static variables here. How we are going to access those information with help of the name of the class name. So using the name of the class name directly, we are able to access the particular methods here. And what about this particular interfaces here? Same way, using this particular interfaces, we can access the name of the method here. Getting the point? So basically this is the specific method. Okay, I'm trying to write the show method, and here we are not going to use this particular super. Directly you can call the show method. Now observe carefully. Getting the point? So basically how we work with the class static method here, same way the same static method we are going to write inside this particular interfaces here. Okay, what is the difference between default and static? Basically, the default method, we need an object here. If I want to call the default method which is available inside the interfaces, we need an object of this particular interface, or we are going to come up with a implementation class. But when we are trying to work with a static method, here we don't need any object. So why we don't need? Because directly with help of this particular interface name, we are able to call the appropriate method here. We are able to call the particular whatever the method we define. So in our example, we define the show method. Now you can see I'm trying to call the method directly here. I'm trying to call the method directly here. Okay. So this is very important. We need to understand regarding this particular static method. Okay. Any questions? And now, so we'll move on to the one of the important concept to call exception handling. So how this particular exception handling is going to work, and what exactly the exception handling will do basically. So whenever if you are trying to run our application, what happens internally? So at compilation time we are going to get an error, and at runtime we are going to get an something exception here. If you miss something, and so those information we need to handle here. For example, if you are trying to divide something or if you are trying to convert something, Getting the point? If you are trying to access the null objects here, what happens internally? So we are going to get an exceptions here. So how these particular exceptions are going to handle internally? So the information we are going to discuss here, and using this particular exception handling here, we'll try to handle the exception. Along with that, we are going to create the new exceptions here. Getting the point? We are going to handle the exception, and along with handling the exception, we'll try to come up with a new exception creation and a new exception handling as well. Okay, so this is, we need to understand the exception handling here. It's nothing but whenever we are getting any error or whenever we are going to get any exception, so those exceptions we are going to handle using this particular exception handling. And internally, the exception handling is going to use multiple keywords here. We'll discuss about the each and every keyword, how this particular the each keyword is going to work internally. Okay, and here what we need to understand, exception, whenever we get any exception in our Java language, we are going to create an object of this particular exception. The object will describe the why we are getting an exception and what is a root cause of the particular exception. Getting the point? Any exception in Java language here, if you get any exception internally, it's going to create an object here. Who is going to create? If you are not handling an exception, by default, compiler will create an object here, and it's going to provide the default message here. As a developer, we can understand the default message, but as a user, we cannot understand what exactly the message contain here. Okay, so using our custom objects here, we are going to like we are going to provide the user understandable messages here. Okay, and what we need to understand here, any error, if we get any error or exception internally, so one object is going to create internally. Okay, the object itself only, it's going to provide the information about so why we are getting the exception here. Okay, why we are getting the particular exception here. And basically here, when an exception, when the exceptional conditional is going to arise, the object is going to create it, and it's going to rethrow the method calls here. So now observe how this particular example is going to work. So first we need to understand how we can handle the exception first. If we get any exception, how we can handle the exception. So using this particular keywords, we are going to handle. First one, we are going to use the try keyword. Why we need to use this particular try keyword? Basically, what we are understanding inside the try, any code. So for example, whatever the code I'm trying to write here, whatever the code I'm trying to write here, so this particular code, so it may be through an exception. It may be through an exception. So those particular code we are going to write under this particular try block. And if really this particular code is going to throw an exception, we have a catch block. We have a catch block. This particular catch block is going to catch an exception basically. Getting the point? So this is the try block and this is the catch block. Inside the try block, what we are doing is, so whatever the code we are going to write, it may be throw an exception. Getting the point? It may be throw an exception, and in case if the particular code is going to throw an exception here, this particular catch block is going to handle this particular exception, and we can write the user friendly messages here. Getting the point? We can write the user friendly messages. And finally, here what I am doing is, we have one more block here. Finally block. So this particular block, if we want to close any resources here, getting the point? If we want to close any resources, so we are going to write this particular finally block. This particular finally block is going to close the important resource what we open, either inside the try block or inside this particular catch block here. Okay, so this is the one of the important example here. Now observe carefully. So if we get any exception inside the try block, whatever the code we are writing, if we get any exception, this particular catch block will call. So for example, I am not getting any exception. What happens internally? The finally block will execute. But even if we get any exception, is also the finally block is going to execute here. Now what you understand here? So if we are getting an exception or if you are not getting an exception, it in the both cases. In the both cases, the finally block is going to execute here. This is important. But here the catch block only is executed whenever we are getting an exception. Whenever we'll get an exception, the catch block will execute. Otherwise, the catch block will not execute. What about this particular finally block? In the both cases, if you get any exception or if you are not getting any exception also, this particular finally block is going to execute here. Okay. First, we need to understand this particular three keywords first, and later we have other two keywords. That two keywords we'll discuss later here. Okay. Now we can see, and here we need to understand the superclass for all the exception classes here, because I discussed about the superclass for all the classes, that is called object here. But this is the class we are going to discuss. It is specific to the exception classes. This is specific to this particular exception classes here. So what is the superclass for this particular exception classes? That is called throwable. Getting the point? So this particular throwable is the superclass for all the exceptional classes. Whatever the exception classes we are going to discuss here. So these are all the exception classes are the subclasses from this particular throwable here. And now this particular exception is internally is going to extended with this particular exception. Exception is also one class. And here, so sorry, this is we are going to discuss about the error. Right now, we don't have much information about this particular error. We'll focus more on this particular exception. And this particular exception internally, it's contain one more class called runtime exception. Getting the point? Runtime exception. This is important here. Okay, so this is the superclass, the throwable, and throwable is extended to this particular exception as well as error. And error we are not going to discuss because this is nothing but system failures, not the Java classes what we are going to discuss here. Okay, and this is the exception. This is the one more exception class we are having, and this particular exception basically is going to getting the band is going to throw an exception, either the checked exception or a unchecked exception here. We'll see what it contains the checked exception and what is contained the unchecked exception. And finally, the exception class internally, it is going to extended by this particular runtime exception here. Okay, so this is we need to understand the hierarchy first. So once we understand this particular hierarchy, we'll see the simple example how it is going to look like here. Okay, now let me run the simple example. Here, why I'm getting this error? Okay, this is a list of something. And here, what I'm doing here, I'm going to create a one package rename. Sorry. So this is the exception. Okay, so the package I modified here, and whatever the example we are going to discuss, everything we are going to discuss inside this particular exception package here. And now you can see, so this is the exception one I'm going to define here. And now, so here what I'm doing here, I'm going to define the int d, and int d is equals to 0 I'm providing. And whenever we are providing this particular d value as a 0, int a is equals to 42 by d. 42 by d. Now I'm trying to divide something. Getting the point? So here basically I'm trying to divide something here. Now whenever so whenever I'm trying to divide something here, now what happens internally? I'm getting an exception here. You can see exception in thread called main thread here. So we'll discuss about the why we are getting this particular main here. Okay. So once we have completed this particular exception handling, we'll move on to the multi-threading concept here. So there we can discuss about the why we are getting this particular main here. Okay. And finally, now you can see what is the name of the exception here. It is a arithmetic exception. Getting the point? It is a arithmetic exception, and what is the message we are having? Slash by 0. Slash by 0. Now what you understand reading this particular exception message here? So basically here we are trying to divide by 0. Whenever we are trying to divide by 0, we are going to get an exception. The name of the exception called arithmetic exception. So who is defined this particular exception? By default, this exception class is provided by our Sun microsystem. So now you can see if I'm going to click on this particular exception. So this is the arithmetic exception we have here, and now you can see arithmetic exception is extending from the which class here? Which class it is extending? Runtime exception. Okay. So now see the hierarchy. So first here I'm having arithmetic exception. So arithmetic exception is nothing but AE I'm defining, and this particular AE is extending from the our runtime exception. Okay, runtime exception. Now if I'm going to move on to this particular runtime exception, now you can see the runtime exception internally is extending from the exception class. Okay, so it is extending internally exception class. Now if I'm going to expand this particular exception class, so what is the super class here? What is the super class here? Something like whatever I discussed just now, something like a throwable. Throwable I'm getting or not here. And if I'm going to expand this particular throwable here, now this throwable basically it is not extending anything. It is not extending any class. It is implementing. Now what you understand? So this is the super class. By default this throwable is extending from the object class. So that is the default extending. But finally, explicitly, this particular class is not extending any other class. So this is the hierarchy we need to understand here. So up to this, the hierarchy we already identified just now. And this is the subclass of this particular runtime exception. So whatever the classes are extending from the runtime exception, whatever the classes are extending from this particular runtime exception, this all the classes will call it as a unchecked exception. Getting the point? This is important here. Unchecked exception, and whatever the classes are extending from this particular exception class, okay, so those we'll call it as a checked exceptions. Those we'll call it as a checked exceptions here. Okay, so this is very important, we need to understand here. So the difference between here, unchecked exceptions are going to extend from the runtime exception, and checked exception classes are going to extend it from the exception class. Exception class. Okay, so exception class can contain multiple classes here. And here, again, the runtime exception is also one of the extending class here. So this is the hierarchy is very important here. So once we understand this particular hierarchy, easily we can come up with what is the exception. Either it is a checked exception or it is a unchecked exception. We can easily understand here. Okay. So try to remember this particular diagram to understand the checked exceptions as well as unchecked exceptions here. Okay. Now what you understand here? Whatever the exception we defined here, whatever the particular exception we defined here, and this is the runtime exception here. So into d is equals to 0, and now what I'm doing here, into a is equals to 42 by d. Now what happens internally? We are getting an exception. How this particular exception we can handle? How this particular exception we can handle here? Because we are getting an exception, so we want to handle this particular exception here. How we can handle this particular exception? But if you see, it's giving me the path of from where it is calling. It is giving me the path also. So you can see this is the package name we have, and this is the name of our class name, and this is our method here. Getting the point? So by seeing this, the exception stack trace here, we can easily understand from where to where it is called and from where we are getting an exception. At line number also, it's going to provide. So this is the name of the class we are having, exercise 1, and line number 7, we are getting an error. So same thing we are able to see here on the line number 7 only, we are getting an error here. Okay. Now, I'm going to provide the method here. So to understand more stack trace here, the exception information, to understand more, I'm going to provide the method information. So something like static void here. So exep, the name of the method I'm defining, and internally whatever the code we have, the code I'm going to make inside this particular method, and finally I'm going to call the method here. From here, I'm calling this particular method here. So again, the same exception we are going to get, but the problem here, so stack trace is going to modify here. So extra new line is added. So this particular new line is added. Now you can see the line numbers also is changed here. So from main, the line number 10 it is called. From the line number 10, internally it is calling the line number 6. At the line number 6 here, we are getting an exception. Getting the point? So at the line number 6, we are getting an exception. So now what you need to understand basically is how this particular stack trace is going to print. So this is the default implementation of this particular exception handling. Now, how we can handle this first? How we can handle this particular exception? So the information using this particular try block. So what I suggested here, whatever the code is going to throw an exception, the section of code I'm moving inside this particular, try block, and if we get any exception, I'm trying to come up with a catch block. So what is the exception we need to handle? Because we already identify what kind of the exception we are going to throw. Let me write this particular arithmetic exception here, and something like ex here. Ex is a reference variable, and I'm going to print the user understandable message here. So division by 0. Division by 0. Now, if you observe the same example, again I'm going to run. Now, what you understand here? Whenever we are handling the exception using this particular try catch block here, now what happens internally? So whatever the message we are providing, like whatever the message we are trying to print, the message printing. But earlier, whatever the default stack trace we are getting here, the default stack trace we are not going to get here. So why we are not getting it? Because we are trying to come up with a try catch here to handle the exception here. So earlier, the exception is by default is going to throw an exception. The exception we are going to handle with help of this particular try catch block here. Okay. So this is very important, we need to understand. And here, the default exception handler. The default exception handler is going to provided by the runtime system here. So the default runtime system is going to throw an exception, and the same way is going to handle an exception. But here, the handling an exception, it's contain the stack trace. Along with the stack trace here is going to provide the whatever the system is provided the message is going to provide. But as a user, as a developer, what we are doing is we are trying to handling explicitly. Once we are handling explicitly, now what we are doing basically, we are going to provide the message. The message as a user can understandable. So what we are doing mistake here? What we are doing mistake basically is, here I'm doing the /0 here. So if I'm going to provide this particular not 0 value, if I'm going to provide the not 0 value, what happens internally? We are not going to get any exception. We are not going to get any exception here. Okay. So by reading this particular as a user understandable message, now what we are doing is basically we are modifying the values. we are modifying the values. So whenever we are modifying the input values, we can get the expected result, not the exception. Not the exception. Now you can see in the console, we are not getting any this particular exception related information. Okay, so this is we need to understand. So to understand here whether this particular method is called or not, how we can check here. So simple message here after this particular try and catch statement here. After catch statement, I am trying to provide the information. Now you can see after catch statement is executing, not the whatever the message we define inside the line number 9 here, inside this particular catch block. Okay, so this is the way we can handle the exceptions and we can provide the user understandable message. Otherwise, so we can provide the whenever we are getting an exception, we can change the input values here. Okay, this is the simple example we identified. So we'll try to continue the same example on Monday. We'll try to focus more onto the exception handling related example. Okay, so any questions or regarding our today's session? Okay, so if we don't have anything, we'll continue on Monday.
Sir,
Yes, tell me.
so classes on Monday mean our Sunday night.
Yes, exactly.
Okay, thank you.
Okay, so we'll see you on Monday.